And so we have an example of a slightly more complicated polynomial. In this case, we have a lead coefficient that is no longer 1. And so we can see it's actually the result of this part of the binomial being 2x plus 3. The factor theorem still applies, but in this case, I have to be careful in exactly how I'm going to choose my test values to substitute into this equation to figure out the binomials. So in this case, I can see that if I substitute x equals negative 3 halves into this set of equations, this binomial factor becomes 0. And so the same thing would happen if I substituted negative 3 halves into this expanded polynomial. This would also equal 0 because these are obviously exactly the same thing. Now, in this case, it's a little bit trickier trying to figure out what values to use here, because now suddenly I have just a dog's breakfast of things. And so this is kind of a rare question where you might be asked to factor these things, and you've got innumerable types that you can try. But here's the rule. Factors of 15 would go on the top. So negative 1, negative 3, negative 5, negative 15. And factors of 2 would go on the bottom. And so negative 1, positive 1, negative 2, positive 2. And those are how you can try the possible factors when you have a slightly more complicated version here.